So the first question is asking us how many electrons need to be present in order to maintain this charge. So we have C, the capacitance is 35 FF. This stands for femtofarads. So this would be 3.5 times 10 to the negative 14th. Again, there are 10 to the 15th femtofarads in every 1 farad. So this would be 3.5 times 10 to the negative 14th farads. And V is equaling 1.5 volts. And again, this is only when charged. So we know that Q equals CV, and we know that Q can also be related to the number of electrons, where N equals the number of electrons, and then E, of course, is the charge on one electron. So if we have a number of electrons, you simply need to multiply the charge on one of the electrons by the number of total electrons there are. That would be your charge, and then we know that charge is equal to the capacitance times the electric potential. So essentially here, N would be equal to CV over E. So this would be 3.5 times 10 to the negative 14th, and then this will be times 1.5 rather, and then divided by the charge on an electron, 1.6 times 10 to the negative 19th coulombs. And we find that we need approximately 3.3 times 10 to the 5th electrons. So this would be your answer for part A, 3.3 times 10 to the 5th electrons. And then for part B, they're asking us for the time it takes for the potential difference to decrease by 2%. So delta Q can be considered 0.02 of original Q. And we, again, delta Q over delta T. This will be the change in charge with respect to time. This is 0.3. Essentially, this is 0.3 femtofarads. So this would be 3 times 10 to the negative 16. And here we're gonna farads. Here we're gonna have to say delta T is equaling delta Q divided by delta Q over delta T. So this would be 0.02 CV, and then divided by delta Q over delta T. So now we can actually substitute. So it would be 0.02 times 3.5 times 10 to the negative 14th times 1.5, all divided by 3 times 10 to the negative 16th. And we find that delta T for part B is going to be equal to 3.5 seconds. So this would be your final answer. And again, this is how long it takes for the potential difference to decrease by 2%. So not to decrease to 2%, but to decrease by 2%. Again, that final answer is 3.5 seconds for part B. That is the end of the solution. Thank you for watching.